Hey everybody, this is Larry. This is day 3 of the February Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. 1043, partition away for maximum sum. Yeah, I'm here again spamming you about my walking channel, so you want to check that out, my journey through Japan. Um, every couple of days, I'm going to try to do every couple of days. I release another episode, and after that, I'll get to Taiwan, and so it's actually a lot of episodes left, so we'll figure it out. But hopefully, it's interesting, or at least just get to walk around and hang out. Anyway, let's take a look at today's problem. I want to make a disclaimer that I'm actually on the gym thing because I think I talk about the gym a lot here, and it's kind of I don't know. Let me know in the comments if you don't care about this at all. Maybe it's I don't know. Just kind of give an update, but it's kind of relevant because I've been doing for this day. I'm currently about I want to say 20 hours, maybe give or take an hour or two. 20-hour fasting, and I'm trying to do a 72-hour fast, so it's gonna be a 3-day fast. Um, yeah. So if I'm a little bit, then that may be why. But the short answer is that I think I've been bulking a lot since I kind of came back, and I've been eating a lot. But it apparently is throwing off my blood sugar level. So I'm trying to kind of reset it a little bit. I thought I was going to gain another like 5-6 pounds before doing the cut. And I don't think I'm doing a full cut, but I am going to at least clean up a little bit first. So yeah. Anyway, let's take a look at today's farm, and we'll see how well I can do on no food for 20 hours. Let me drink some water because it's better than nothing. All right. Given an integer array, partition an array into contiguous subarray of length of at most k. After partitioning, each subarray has its value changed to become the maximum value of that subarray. Within the largest sum, okay. What's k? Oh, k is the length. Oh, I thought it was just for partition. It you just consider the largest, but in here, it seems like it actually is it actually changes them to like k times n. Okay, that's actually a little bit interesting. I mean, the first thing I would notice is that n is 500, so we can do something about like n squared. Maybe. We have to be a little bit careful. How would I think about this? Maybe the hunger is starting. Okay. But So for this one, we want to maximize. So the idea, or my initial idea, I don't know the answer yet. Just to be clear, even though this is a medium, I don't know. My initial idea is going to be that okay. Well, the observation is that and I don't think this is greedy, but if we were to think about a greedy strategy to kind of play with ideas, then we want like the max number to kind of surround all that it can, right? And then the question is, I don't know that there is a greedy exchange argument. Because the reason why I say that is because this is a hugely different problem. You want to maximize and minimize, right? So that's why I'm kind of I guess minimize is actually a dumb problem, because, at least the way that in its exact preciseness, because then you just have every number for itself, because you can only make things worse if, in this case. So I guess, yeah. In this case, we want to maximize. Huh. I mean, given that n is 500, I mean, I was trying to think about some strategy, to be honest, and then try to prove those strategies. Like if I had a greedy strategy, I would have to prove greedy. But also, to be honest, maybe that was a little bit silly, because given that n is 500, my other thought may be just dynamic programming, right? Yeah, I mean, maybe. I'm still trying to think through the greedy-ish thing, but I don't know. Yeah, but DP maybe is reasonable because then now, okay, what would DP look like? Right. So basically, maybe we have something like get max index, right? And I don't know the dimensions yet, but you know we want to keep it n square or n square log n at most for 500. That's my kind of back of the head envelope, right? So here, and I don't know if that these are the dimensions yet. I guess actually this makes sense. Okay, but the idea here is that you know, get max gets the max after partitioning, starting from index, right? Yeah. So that means that everything before that has already been partitioned, and you already got a score, so you don't have to worry about it. And in that case, then now you can brute force just taking k is equal to 0, 1, 2, or not k is equal to, but like I is equal to 0, 1, 2, well, I guess 0 doesn't make sense, but 1, 2, 3, dot, 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 all the way to k. So I think that makes sense then, right? So if this is greater than n, then we return 0 because we're done. So I guess in this way, it's actually not that bad. Usually I'm pretty good at DP, but today maybe a little bit shaky about it. But yeah, but basically now here we get up to k, right? Something like, okay, so the best is equal to 0 because we want to maximize. So it's just a sentinel value. Maybe we could do negative infinity if you want to play with that. I don't think there's any negative numbers, so it should be fine either way. But then yeah, and then oops. And then maybe current max is equal to 0 as well. And then here we go, current max is equal to max of array sub I, or index plus I, or current max, right? And then here the idea is that now we can do recursion, right? Because we we get max index plus I, right? And here we have to kind of make sure that index sub I is this is less than or equal to, or less than n, right? Something like that. And you can maybe terminate early. So you can do something like, I don't know, right? Even this looks kind of yucky, but for now we'll focus on this. Right, so here, this is basically what you want to do, plus 1, because this index is already into the current max. And then the score that you get is actually equal to current max times I plus 1, right? Because I plus 1 is the number of numbers that you took. So yeah, and that's pretty much it, I think. In the concept, of course, we have to do dynamic programming things. I'm gonna run it real quick. Looks okay, and yeah, and of course, like I said, this kind of branches out. Oops, this kind of branches out a couple of times, right? So of course, we want to, yeah, we want to memorize. So let's do it. Man, I am really off right now. Sorry. And sometimes people ask me why I separate them out. It just makes it easier to read this part of the code, and just make all the space kind of explicit. But yeah. I'm going to do an extra problem after this because I apparently already done it, though I did struggle a little bit with this. But yeah. 1404 day streak. Yeah, and this is going to be linear space because we only have linear number of inputs and each of them is all one space. O of n times k times, because, well, I mean, there's only O of n inputs and this takes O of k at most. Of course, k could be at most n, I think. I don't remember. Yeah, so you could say it's O of k times n or O of n squared. But either way, you know, that's pretty much it. Don't know why I struggled with this one. I mean, I thought I did okay. Oh yeah, I guess I actually wrote pretty much the same code last time, but I just felt like mentally, that's the problem with greedy solutions sometimes. Sometimes it's just so like intoxicatingly enticing, right? Because you're like, oh, I feel like there may be, but then, you know, I think some of it that I cheated a little bit in that I kind of look at the constraints and like, okay, n is equal to 500. I don't have to, like, you know, n squared is going to be fast enough, or n times k is fast enough, so I'm going to do that. But I don't know. But yeah, that's what I have for this one. I'm going to do a bonus one after this, so stay tuned. Yeah, that's all I have. Come walk with me. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.